The Biomedical Research Tower stands tall over the OSU campus, but down in the basement in a small lab, the hum of a 3D printer creating a new part, a new body part.
I'm holding a piece of the jaw here.
Right.
Is that right?
A piece of plastic with the potential to heal. These researchers at OSU are working on the next generation of bone and tissue engineering, crafted from a computer and a 3D printer.
What it's doing is taking that shape, cutting it into slices that are then printed one after the other.
If the color looks odd in this lab, it's because of the special lighting necessary for this research. Notice all these holes and lines. Think of them as channels for growing the bone. They'll be infused with stem cells, put in a bioreactor, and then grow into a surgical implant custom designed for a patient. Dr. David Dean has been working on this for 20 years, and he is confident it is the future.
We'd get a CT scan from anywhere in the world, design the implant, print it, get cells from the freezer from somebody else, seed that, culture bone on it, and send it to wherever it's needed.
A process from start to finish in 3 weeks, all from a computer design and a 3D printer. But think of it as creating, growing, rather than printing. This animation from OSU shows how cells are attached to the graft and then grow from there. The impact? From creating new organs to healing wounds before a limb has to be amputated, to reconstructive surgery using 3D printers to build custom implants. And there is a race for this research all over the world. This man's story made the headlines in the UK. His face reconstructed after a motorcycle accident using parts created from a 3D printer.
And that's one of the limiting things with bone tissue engineering is, can we produce strong bone?
It's just a piece of the puzzle in regenerative medicine unfolding at incredible speeds. And even the Defense Department is investing in Dr. Dean's research for our soldiers.
More than a quarter of the battlefield injuries involve the face and skull. And of those, more than a quarter are going to involve major traumatic injury to the upper and lower jaw. So it's a huge need.
Regenerative medicine holds the power to reshape medicine. The plastic is cheap, the research priceless, and the future, uncharted territory with limitless potential.